with Gloria and Nubo. Today, let's share some information about repeat prototyping and low-value manufacturing. If you have any questions, feel free to ask in the comments, and don't forget to follow me. Okay, the first one is what's the repeat prototyping service? Repeat prototyping is the process of creating a physical sample of a new product design concept. Hi guys, welcome to my channel. If you have any questions, leave your words in the comments. So I will answer the question. Alright, let's begin. This about repeat prototyping. This is done as a preliminary step before final production and is particularly beneficial when ensuring that the finished product looks and feels and performs as anticipated. Repeat prototyping is used by new product developers for a variety of reasons. They are used for functional testing and approvals, design reviews, and co-funding, and the traditional model as a stepping stone to low-value manufacture. Prototypes frequently inspire redesigns and refinements and other changes that would not have been visible from a computer graphic. Therefore, they are useful for optimizing a design. Hi, welcome to my channel. Today, I will share some information about repeat prototyping. So if you are interested, let me know and leave your words in the comments. Alright, so about the repeat prototyping, we correctly design from earlier in the development process can more than offset the costs of the prototype, making them sensible investments. So maybe someone will want to know what the advantages of repeat prototyping. That's maybe I will tell you the repeat prototyping assists you in marking the most of the stage of the product development cycle. Working with professional engineers and have various advantages like reduced costs and supporting functionality testing and reduce risk and save time. So let's detail to talking these advantages. About the first one, reduce costs. And the repeat prototyping allows you to swiftly and efficiently turn your concept into a test subject. Earlier in the development process, time-saving months get you one step closer to efficient products that pay for itself. Whether you are one global brand or a tiny firm, any cost-cutting measure can boost your bottom line. Yeah, the next one is the supporting functionality testing. Your prototype accuracy depicts how your product looks and functions. Testing and retesting allow you to fine-tune your idea and transform them into successful solutions that are more likely to succeed. Does it provide a good user experience? Yeah, is it achieving your objectives? At point, you can identify characteristics that require additional improvement and perceptive area for expansion. If you product designers identify significant concerns during the testing phase, those crucial design defects can be addressed before your product is released to the public. It's considerably easier to correct a prototype than it is to fix a product that has already been sent to customers. A thorough review of your design reduces the likelihood of failure in the long run. Its next is rapid prototyping is a value means for saving time during the development process by quickly creating and iterating prototypes of a product or solution. It, it allows you to validate ideas and collect feedback and make necessary improvements before investing significant time and resource in final implementation. About Rapid Prototyping Factory, what kind of services are included in rapid prototypes? Various technologies are available for rapid prototyping in manufacturing, including layered additive manufacturing, high-speed machining, and casting, molding, and extruding. Additive manufacturing is the most popular process for rapid prototyping. Traditional process including subjective and additive manufacturing. Subjective manufacturing counts a block of material to create the desired parts, while additive manufacturing applies solid or liquid material to the designed shape. You can select it from a material of rapid prototyping means for your production requirements. Yeah. So depend on the rapid prototyping firm you deal with, and distinct process have distinct benefits. Give your manufacturing company flexibility and variety. Yeah. So types of rapid prototyping is including CNC prototyping. CNC prototype machining is a good alternative since it can produce most quantities of a rapid in a reasonably short time when compared to other technologies. CNC prototype machining makes it simple to create many types of prototypes. Appearance, appearance prototypes, for example, can offer visual information about how the final elements will look or behave. However, functional prototypes require greater tolerance and greater emphasis on product structure and stability. So about the advantages of CNC machining for prototypes also can be cost effective. If you only require a few prototypes, CNC machining is the most cost effective alternative. Unlike injury molding, which may take many months to prepare the model and tolerance, CNC prototype machining can begin independently after the layout and tolerance are established, and also have high tolerance. Another feature that contributed to the rapid development of rapid prototypes is their large tolerance range. Unlike 3D printing, your prototypes can be as in check age and as the end product. That is a significant benefit for those who intend to use the prototypes for structure and functional testing. High CNC machined prototypes as opposed to 3D printed prototypes have numerous similarities to the product because machining centers are completely capable of generating and use parts and prototypes. prototypes that are near to the final product can be made. One of the reasons engineering methods are favored for prototyping is their exceptional machinability. This means that engineers can utilize the same and similar materials for prototypes and final parts. Furthermore, unlike printing parts, machined products are generally stronger and do not have any weak points along specific axes. However, the machining process can also be used to duplicate other operations such as sheet metal shaping. So the next is vacuum casting. Vacuum casting is a manufacturing mount for making accurate prototypes or low-value goods. Under vacuum, liquid materials are injected into a silicon model to ensure flawless replication of tensing features and equal material distribution. So the advantages of vacuum casting: fine details and texture are properly captured by vacuum casting. It enables material flexibility by utilizing several polymer and resin. So the vacuum casting is a casting effective way for casting quantities. Prototypes and small batch production have short lead time. It's a good advantage for you if you are in a hurry to want to know this order complete. So the next is design flexibility with sophisticated parts and complex geometry. Vacuum casting prototypes are useful for testing and validation before to production. And now I will show some information about injection molding. Prepared injection molding injects thermoplastic regions into an aluminum model, producing strong and high-quality parts. Is industry standards for plastic part production and allows for material flexibility in prototyping. Advantages about the molding parts are created using an iron of high-quality materials, have an exceptional surface finishing, and serve as an silent indicator of manufacturing flexibility during the production process. And we also have the 3D printing service. Rapid printing comes in various forms depending on your requirements. Each bundle will provide you with different features, and choosing the proper fast prototyping tag for your production is crucial to achieving the drastic result from your manufacturing procedure. So before deciding on the best solution for your manufacturing process, you should consult with the quick prototyping firm with which you are working. So how to choose a rapid prototyping service? How? It can be a challenge to select the best rapid prototyping service, particularly when time is a crucial factor. Having complex designs doesn't always mean shorter lead times. The materials utilized are also significant in terms of scheduling and budgeting. So it's important to have clear understanding of all aspects before setting expectations. Here are a few things to consider. Firstly, there are several questions you need to consider. The first one is in my design too complex for an integrated and functional model, and the next one is which is more important to me, the quality or speed or price. And the next is what is made from. Maybe you want to know made from China or other countries. And how important are strength and durability. The last one is how closely should it match the final production vision. If you have considered these questions when you order this project, so I think it's necessary for you. Alright, next is consider the project purpose. The professionals who provide a quick prototyping service cannot determine the objective of your design. That is something you must accomplish before starting a project. However, prototyping experts can assist you in determining the most productive and efficient and cost-effective technique. Yes. And the next is think and confirm the project deadlines. Many people consider rapid prototyping service to be fast manufacturing due to their expanded molding capabilities. However, some orders may take longer than others. Your project deadlines are crucial, but multiple variables could affect the schedule plan accordingly. And choose versatility and cost-effective quick prototyping service. Discuss with your team how you may cut costs while keeping the integrating of your prototype design. Consider the impact of materials and accuracy standards, supplies and ISO standards, and industry trend on your final cost. And the tips to select the rapid prototyping manufacturing. There have selecting a manufacturer to make your items is an important design, and finding the correct match difficult in the for committing to any production speed. When you know what to look for cooperating with prototyping business should be a breeze. Here are some elements to consider when looking for a manufacturing to bring your prototypes idea to life. First one is industry experience. The best prototyping business will have a portfolio and where you can look over the previous work. This information is crucial in determining whether they have previously handled similar projects and specialized in the types of prototypes you record. You will record an experienced firm in your industry throughout the earlier stage of product development. They have a greater understanding of the material to utilize. The machines can be employed for the end product, and your industry the terminologic and working with such prototyping in business will greatly simplify the manufacturing process. The second is manufacturing capacity. Production capacity is crucial to the company's success. After launching a prototype, you must maintain sequence order within the specific delivery period, and the only way to help with this is to select the prototyping business that can handle and deliver a huge order even after the prototyping is over. Yeah. So do your homework before selecting a specific company or manufacturing to guarantee that the company can handle your type of business. This will save your money on trials and errors, as well as time wasting seeking a new manufacturer if you have large order for your product. Yeah, and the third is ISO certification. In the engineering and industry sectors, ISO certifications and compliance standards are crucial. Certified prototyping companies have passed an audit by an impartial agency because they exceed the defined standards and provide super quality assurance. Choose an ISO compliance business for higher quality prototypes. It's very good for you. And the next one is quality assurance. In any industry process, quality assurance is crucial, and working with business that build product prototypes ought to be of the highest caliber, and a manufacturing that protects quality control is less likely to create parts or components that are flawed. Every step of the production cycle will see quality assurance testing performed by a repeatable business. So the 5 is design support. If you are an entrepreneur and are working with prototyping companies for the first time, you may not have experience in most manufacturing process. Therefore, it's crucial to ensure that the manufacturing partner you choose provides consistent feedback and advice. Yeah, so a good prototyping company should always offer your suggestions, advice, and opinions regarding the best materials to use and the right process to follow. Therefore, if you are unsure about which process to use, there is no harm in seeking advice for the company. So maybe someone wants to know about curious about what's the low value manufacturing. Making thousands or millions of identical components or products at a cheap cost. Pure unit is the main goal of modern manufacturing zero and tools and best practice. Customer and low value production demands a wholly distinct set of techniques. So, and try to modify mass production systems to fit present special delivery for products. So low-value manufacturing refers to production runs that manufacture a limited number of parts, ranging from 10 to tens of thousands. So most traditional manufacturing mounts, such as molding or forming, are designed for mass production, which involves producing large quantities of the same items. While those techniques are highly cost-effective for high-value production, over 10,000 parts. Yeah, so they require standard, expensive machinery and tooling, which rarely allow for product modifications. The cost is higher and the manufacturing time will be longer by weeks or months compared to large-scale production procedures like injection molding. Manufacturers can employ high-value orders to advance those large upfront capital expenditures through mass production. As the cost of each part drops when it's spread over thousands of pieces, the capability to make specialist or highly customized parts at a reasonable cost is limited by the mass manufacturing procedures that are intended to generate identical parts in huge quantity. On the other hand, high mix low value manufacturing, sometimes referred to as a customer manufacturing or the production of goods according to specific requirements, has historically been done by hand in tiny workshops. Because of the large percent of manual labor and reduce through this leading to a higher cost per parts for customer items. For the same reason, mass customers the production of huge quantities of limited customer goods. Yeah, so the advantages of rapid prototyping as low value production have reduced costs and high speed and flexibility and customization. So, and that's all is today. I will show you the details, the value casting. So the next, let our partner to Lucy to share the details and other technique for you.
Hello everyone, I'm Lucy. Today I will introduce you a new process, blow molding. Blow molding is a manufacturing process for forming holoplastic parts. It is also used for forming glass bottles or other hollow shapes. In general, there are three main types of blow molding: extrusion blow molding, injection blow molding, and injection stretch blow molding. The blow molding process begins with softened plastic by heating a platform or paraffin. The paraffin is a tube-like piece of plastic with a hole in one end through which compressed air can enter. The plastic workpiece is then clapped into a mold and air is and air is blown into it. The air pressure inflates the plastic, which conforms to the mold. Once the plastic has cooled and hardened, the mold opens. The part is injected. Water channels within the mold assist in cooling. The process principle comes from the idea of glass blowing. Inotre Fragrant and Williams Copker produced a blow molding machine and sold it to Hartford Empire Company in 1938. This was the beginning of the commercial blow molding process. During the 1940s, the variety and the number of products were still very limited, and therefore blow molding did not take off until later. Once the variety and the production rates went up, the number of products created soon followed. The technical machinery needed to produce whole body workpieces using the blowing technique were established very early on. Because glass is very breakable, after the introduction of plastic was used to replace glass in some cases. The first mass production of plastic bottles was done in America in 1939. Germany started using this technology a little bit later, but is currently one of the leading manufacturers of blowing molding machines. In the United States soft drink industry, the number of plastic containers went from 0 in 1977 to 10 billion pieces in 1999. Today, an even great number of products are blown and is expected to keep increasing. For amorphous metal, also known as bond metallic glasses, blow molding has been recently demonstrated under pressures and temperatures comparable to plastic blow molding. In the first kind of blow molding is extrusion blow molding. In extrusion blow molding, plastic is melted and extruded into a hollow tube, forming a tube-like pieces of plastic with a hollow in one end for compressed gas known as a person. The person is captured by closing it into a cold metal mold. Air is blown into the person, inflating it into the shape of the hollow bottle, container, or part. After the plastic has cooled, the mold is opened and the part is injected. Heat extraction blow molding is a way of propelling material forward similar to injection molding, whereby a intermediate screw turns, feeding plastic metal material down a heated tube. Once the plastic is melted, the screw stops rotating and linearly moves to push the melt out. With the accumulator mass, an accumulator gathers melted plastic, and after the previous mold has cooled and enough plastic has accumulated, a load pushes the melted plastic and forms the parison. In this case, the screw may turn continuous or intermittently. With continuous extraction, the weight of the parison drags the parison and makes calibrating the wall thickness difficult. The accumulator heat or reciprocating screw must use hydraulic systems to push the parison out quickly, reducing the effect of the weight and allowing precious control over the wall thickness by adjusting the die gap with a parison programming device. Continuous extraction equipment includes rotary wire blow molding systems and sheet machinery, while intermittent extrusion machinery includes reciprocating screw machinery and accumulator heat machinery. By trimming, containers such as jars often have an excess of material due to the molding process. This is trimmed off by spine a cutting blade around the container which separates the material. The excess plastic is then recycled to create new moldings. Spine trimmers are used on a number of materials such as PVC, HDPE, and PE and LDPE. Different types of the materials have their own physical characteristics affecting trimming. For example, moldings produced from amorphous materials are much more difficult to trim than crystalline materials. Titanium nitride coated blades are often used rather than standard steel to increase life by a factor of 30 times. The second is injection molding. Injection molding. This process of injection molding is used for the production of hollow glass and plastic objects in large quantities. In the injection molding process, the polymer is injection molded onto a coping. Then the coping is rotated to blow molding station to be inflated and cooled. This is the least used of the cerebral molding process and is typically used to make small medical and single-serve bottles. The process is divided into three steps: injection, blowing, and ejection. The injection molding machine is based on an extruder barrel and screw assembly which melts the polymer. The molten polymer is fed into a hot runner, then fold where is it injected through nozzles into a heated cavity and cupping. The cavity mold forms the external shape and is clamped around a cold rod which forms the internal shape of the preform. The preform consists of a fully formed bottle dry neck with a thin tube of polymer attached, which will form the body, similar in appearance to a test tube with a threaded neck. The preform mold opens and the core rod is rotated and clamped into the hollow. Child blow molding. The end of the core rod opens and allows compressed air into the preform, which inflates it to the finished article shape. After a cooling period, the blow molding opens and the core rod is rotated to injection position. The finished article is stripped of the core rod and as an option can be leak tested parallel to picking. The preform and the blow molding can have many cavities, typically 3 to 16, depending on the article size and the required output. There are 3 sets of core rods, which allow concurrent preform injection, blow molding, and injection. The third is injection stage blow molding. Injection stage blow molding has two main different methods, namely single stage and double stage process. The single stage process is then again broken into 3 station and 4 station machines. Single stage. In the single stage process, both preform manufacture and bottle blowing is performed in the same machine. All the 4 station method of injection, reheat, stretch, blow, and injection is more costly than the 3 station machine, where eliminates the reheat stage and use latent heat in the preform. The saving cost of inert to reheat and 25% reduction in taurine. The process planned. Imagine the molecules are small rod balls. When together, they have large air gaps and small surface contact. By first stretching the molecules vertically, then blowing to stretch horizontally, the biaxial stretch makes the molecules cross-strip. These cross fit together leaving little space as more surface area is contacted, thus making the material less porous and increasing barrier stretch against permission. This process also increases the strength to be ideal and for filling with carbonated drinks. Two-stage. In the two-stage injection stretch molding process, the plastic is first molded into a preform using the injection molding process. These preforms are produced with the necks of the bottles, including threads, the finish on one end. These preforms are packaged and fed later. After cooling into a reheated stretch molding machine, in the injection stretch molding process, the performance are heated, typically using infrared heaters above their glass transition temperature, then blowing using high pressure air into bottles using metal bromobs. The preform is always stretched with a core rod as part of the process. The principle and the classification of the process have been finished. Next, I will introduce another process, injection molding. Injection molding is a manufacturing process for producing parts by injecting molten material into a mold or mold. Injection molding can be performed with a host of materials, mainly including metals, for which the process is called die casting, glasses, elastomers, confections, and most commonly three plastic and thermosetting polymers. Material for the part is fed into a heated barrier mixture using a helical screw and injection into a mold cavity where it cools and hardens to the configuration of the cavity. After a product is designed, usually by an industrial designer or an engineer, molds are made by a mold maker or tool maker for metal, usually either steel or aluminum, and pressure machine to form the features of the designed parts. Injection molding is widely used for manufacturing a variety of parts from the smallest components to entire body panels of cars. Advances in 3D printing technology using photopolymers that don't melt during the injection molding of some lower temperature thermoplastics can be used for some simple injection molds. Injection molding uses a special purpose machine that has three parts: the injection unit, the mold, and the clamp. The parts to be injection molded must be very carefully designed to facilitate the molding process. The material used for the part, the design, shape, and features of the part, the material of the mold, and the properties of the molding machine must be taken into account. The versatility of injection molding is facilitated by these breadth of design considerations and possibilities. Applications. Injection molding is used to create many things such as wire spoons, packing, bottle caps, automotive parts and components, toys, pocket cups, some musical instruments and parts of them, one-piece chairs and small tables, storage containers, material parts including gels and most other plastic products available today. Injection molding is the most common modern mass or manufacturing plastic parts. It's ideal for producing high volumes of the same objects. What is the difference between blow molding and injection molding, and what they have in common? Injection molding and blow molding are both high production volume manufacturing technologies that form plastic into many different shapes and sizes. Injection molding is used for complex solid components, whereas blow molding is used for thin-walled hollow parts. Injection molding forces plastic into a mold on high pressure. Blow molding, on the other hand, expands a hollow tube of plastic into a mold using compressed air. Blow molding is generally cheaper than injection molding. This is because blow molded products are less complex, and therefore the required tooling is cheaper. In addition,
买家在声想看直播，打个招呼吧。
injection molding requires heavy-duty hydraulic rings to inject the plastic raw material and to keep the mold from becoming plastic during the injection phase. Blow molding can produce single component hollow containers which would be impossible to make with injection molding. Blow molding is also less expensive than injection molding. Blow molding is performed at lower pressure than injection molding, allowing the use of less expensive tooling and equipment. Blow molding is only applicable to thin welded hollow parts. That being the case, it is limited to such applications. It can't be used for store products. The Parison needs to be trimmed off at the top and and the bottle of the part after molding. Injection molding typically requires no poster, no surface finish. In summary, molding is more cheaper, but if you need paint or good surface finish, it will be cost a lot because the surface is very low, but the products made of injection mold is smooth. We can do some surface finish directly. So choose molding and injection molding. Uh, except for the cost, we also need to consider the surface effect what you want. Next time I will introduce other process like shipmental and 3D printing and die casting or about if you are interested in mass production process made of metal, we can I will introduce the die casting and sheet metal and other process next time. That's all information I introduced. See you next time. Bye.